Hello students, in today's class we will see inverse Z transform of rational algebraic functions by partial fraction methods. So here how the problems are going to simplify. So what is the working procedure of the problem we will see today. So inverse Z transform. So here step number 1 to solve the examples are what here. So given u dash, so here u dash is nothing but u dash means inverse z transform we are going to find. So given u dash of z is equal to, it will be in the form of what here, a fraction, that is f of z divided by g of z. So we need to express denominator, that is g dash g of dash in terms of what here, non-repeated linear factor only. We need to remember what here. So first, given u dash of z, which is in the form of f of z upon g of dash, we need to express g, that is denominator, that is g of z in terms of what here, non-repeated linear factors only, because we can what here, whatever formations are there in the standard list of the inverse z transform, that g dash should be fit for that, so that we can easily solve the problems. So once we get this, so step number 2 is we consider u dash of z upon z in the form of the proper fraction and resolve into partial fraction. Means from the given function we need to take a common z, and that should be cross multiplied. Means from here, so what we have step, from this f of z we have to take z and we need to cross multiply to the what here, u dash of z, it will become in denominator, so that we can right hand side whatever functions is going to left, which is in the form of what here, fraction, that fraction will be resolved using what here, partial fraction. So step number 3, we multiply z to have u dash of z involving various terms of the form c into z upon z minus k, where this c being a constant. So after solving, we'll get what here, one of the partial fraction. If you solve, you will get the values of that respective constant, that is a, b, c, whatever we'll choose. So that value is nothing but here c, so that c should be what here kept outside, and we need to apply what here, inverse z transform to that. So step number 4, finally we compute the inverse z transform of these terms, resulting in the required z inverse of u dash of z. So these are the steps. So hope you got the point. So with the help of this, we'll try to simplify the inverse z transform, which is of the form what here, in terms of z, and we'll transform that z in terms of what here, n. So we'll see one of the important note also here. That note may help us to simplify the this inverse z transform. What is that note? We'll see. Note: if g of z, that is nothing but denominator of our u dash of z, involves repeated linear factors of the form z minus k whole square, or z minus k whole cube, or z minus k whole raised to 4, so on, we need to take it into account the corresponding terms in the numerator. So in the numerator, if the numerators are k minus z minus k whole square, so we have to choose our numerator, okay, like kz, or kz square plus k square z, or kz cube plus 4 k square z square plus k cube z, so on. Many things, means we need to, by seeing the denominator, we need to rearrange what your numerator, so that we can express our uz suitably with the terms multiplied by what here abc, and we compute abc. Then what we'll do here, we compute abc and find what here z inverse of u dash of z. So just this is a note you remember, so that once we start the examples you can understand that. So we'll see the examples and in detail how this z inverse will be simplified.